Okay, so we're going to do a little basic algebra stuff here. And we did a lot of this in geometry as well. I teach geometry, and we did a whole bunch of this. Well, let's just talk about the word slope. What's the slope? And we're not even going to get really into like equation of a line just yet. Okay, we're just going to talk about the slope today, and that's about it. Since you took a quiz, we'll kind of take it easy today a little bit. All right, so if I had a line right here, and it's slanted, right? It's not horizontal, it's not vertical. Okay, it's slanted on a diagonal, I guess if you want to call it. It's got a certain steepness to it. Watch, if I take the same exact line, and let's touch that there, and watch. If I do this, now I didn't change the length or anything, did I? What am I doing, though? I'm changing how what? What word did I use? Steep, right? How steep it is, right? So this line right here, this second line that I'm moving around right here, compare that to the first line. Is that steeper or flatter? It's steeper, right? And then if I went like this would be what? It'd be a little flatter, wouldn't it? Okay. So the steepness of the line is the slope of the line. All right. So if I wanted to talk about these two lines, which line is steeper? Well, this line looks steeper. If you're going to climb up a hill, right, and you're starting down the bottom, you're going to climb up this hill, that would be a steeper climb than this climb right here. Make sense? Yeah. So that's what we're going to talk about. We have to indicate like how steep it is. We have to tell somebody, okay, this line has a certain steepness. My family's from West Virginia. We go to West Virginia all the time, and you see some signs when you start really getting into the hills of Western Maryland and West Virginia. You see some signs that tell you how steep the road actually is, because a lot of truckers have a hard time, especially going downhill. Going uphill is tough. They might go a little slow. They usually can make it up these hills, but going downhill is a problem for these truckers. Why do you think going downhill is a problem for these truckers? Okay, what do you like, the pig on the commercial with the three little pigs go home or whatever they call it? Anyway, what do you think? Come on, what about truck? Why do you think a truck cares how steep the hill is when you're going down the hill? Yeah, truck's really heavy, and say it. Somebody said something. What? Come on, talk to me. No idea? The brakes, absolutely, the brakes. Okay, that has a lot to do with it. Truck's heavy, right? And it's the brakes. I knew you knew it. I just wanted somebody to say it. Okay, absolutely. If you're going down a really, really steep hill compared to a flatter hill, let's do this again. So watch. If you're a truck and you're going down a hill like this compared to a hill like this, your brakes are a little bit more important going down a hill like this, aren't they? And they give you the grade. They give it to you usually as a percent. I forget exactly what the number was in West Virginia. I think for some reason I'm thinking 6%, a 6% grade maybe. Does that sound, anybody have any idea? I don't know. I just remember that. Next time I go to West Virginia, I'll look at the sign and remember. Okay, but I think it's 6% grade. That's one way of telling the slope of a line, okay? And the truckers need to know that, because, you know, a trucker going down a hill, it'll determine.
If he makes it down the hill.
So what are you going to do with it? There you go. So yeah, they got to figure out going down the hill what's the slope of the hill. So anyway, let's talk about what the slope is. So let's put another line here, and let's talk mathematically. We're not going to do it as a percent though. Okay, we're not going to say it's a 6% slope or anything like that. We're going to use two numbers. All right, and you can use any 2 points on the graph itself. All right, I'm just going to use the endpoints of this particular one, but you can use any 2 points, because to tell you the truth, watch. Is it any steeper going from here to here than it is from here to here? No, it's no steeper, is it? Okay, now you're a little higher, all right, you know, if you talk about altitude or something like that, but the steepness is exactly the same. It's the same line, right? It's not two different lines. It's the same exact line. So it doesn't matter between which 2 points you're finding how steep this line is, okay? So if it's one line, it doesn't matter which 2 points you use. I just decided to use the endpoints, all right? And let's call this x1 and y1. Okay, we've dealt with this x1, y1 stuff before. We did it with distance formula. We did it with midpoint formula. Okay, we're going to do it again with slope. So we'll call this the first point. We'll call this the second point. So what's this point going to be? This is going to be x what? 2 and y2. All right, so those are my 2 points. If I want to find out how steep it is, whoever came up with this came up with the idea of let's compare how high it is compared to how far across it is, okay? And that's going to give us how steep the line is. I guess you could have compared how far across to how high, but for some reason they did how high. Well, actually, yeah, let's go from 1 to 2, watch. So they did this. They figured out how high this thing is, and that's a certain number, compared means it's going to have a ratio. Okay. Everybody paying attention? Jay, you all right? Let's look up here and let's watch this. Okay, so we're comparing up and down to across. Now, when you did this in Algebra 1, what did we call? We gave a word starts with an R as far as going up and down. We called that the rise. Good. Okay, so you remember that stuff, don't you? And then we got going across. What do we call going across like this? We call it the run. So when we find the slope of this line, how steep this line is, we compare those two numbers. This is a certain number. I'm just going to make one up. Let's say that that's 5, and this is like, how about 7? All right, so let's say this is 5. What's that? I always do what? I always use 5? Is that what you said? No? Okay. So let's compare the rise to the run. And that's going to be the slope of this thing. So if I said the slope is equal to the rise compared to the run. All right, it's a ratio. It's a fraction. It's rise over run. So in this case, if I started from this point down here and I wanted to go to this point up here, I would rise 5 and I would run 7. So the slope of this line is 5 over 7. Now, if you wanted to, you could write this as a percentage. I'm just curious to see what that is. Okay, so 5 divided by... Now, you're not going to do this. I'm just curious, okay? So it's 0.71, or what would that be as a percent?
71.
It'd be 71%. That's a pretty steep hill, all right? So you wouldn't see a hill like that on a road. They wouldn't make a road that steep because I think that's how they would compare it. Yeah, that's about right. Yeah, so yeah, they wouldn't make a road that steep on a hill because the trucks would never be able to get down it because the brakes wouldn't be strong enough to hold the truck. All right, but anyway, we're not going to write it as a percentage. We're going to keep it as a fraction. So do not do what I just did by putting it into a calculator. All right, just keep it as a fraction. Now, if your fraction didn't come out, or if it needed to reduce, then you should reduce your fraction. Okay, so always reduce your fractions, and that would be the slope. Simple as that. It's the rise over the run. Well, here's another way that we talk about it. Like this point right here, basically it's finding the length of the y values, isn't it? And this is finding the length of the x values. So if you remember that, if I wanted to find this thing right here, I would just subtract the y's, wouldn't I? Okay, so if I wanted to find the rise, watch this. If I wanted to find the rise, I would just subtract the y values from each other, right? Because that's going up and down, isn't it? That's vertical. It's the y values. So I subtract the y's. So y1 minus y2. And it doesn't matter what order you subtract them in. But if I do the same thing with the run, I have to subtract them in the same order for the run. So the rise is y1 minus y2. And the run is, what do you think? x1 minus x2. Very good. Make sure you subtract the x's in the same order as you subtract the y's. I could have gone y2 minus y1, but if I would have done that, what would this be? x2 minus x1, okay? So subtract the y's from each other and subtract the x's from each other. The y's go on top, so it's rise over run, and that's your slope right there. Okay, y1 minus y2 over x1 minus x2. It's another formula. This is like the third formula, isn't it, that we've dealt with x1s and y1s and x2s and y2s. We did distance, we did midpoint, now we do slope. And you have to know the difference between those two. The problems all kind of look the same because they're going to give you 2 points. They're going to give you, and I'm just going to make up a point. Let's say -3, 1, and 5, we'll go 5, 7, okay? All right, so if I wanted to find the slope of this, the slope, by the way, we actually give this a letter. You would think the letter would be S for slope, wouldn't you? But for some odd reason, what's the letter? It's M. It's M. Now, I've actually looked that up. Can you believe that? You probably do, right? You probably think that's all I do every night, right, is look up stuff like this.
Yes.
But I've taught this for so long, and I never knew what the M actually stood for. I looked it up, and there's still actually debate. If you read online, there's actually debate on what the M actually stands for. That it's not like they know for a fact it comes from this particular word or whatever. But they think, I think most people believe that it comes from a Latin word, and the Latin word it's kind of derived from like a mountain. Like the M doesn't really stand for mountain, but it's a Latin word that has something to do with mountains and hills and you know how steep something is. Okay, and that's where the M. That's where a lot of people think the M comes from. And there's different points of view on where this comes from. But I kind of like that idea. Okay, think of M as mountain or Latin for mountain. Okay, and that's what it means. So that's where we get the M from. If you always wondered, did you ever have a teacher tell you where the M came from? No, I never did either. Okay, and I never taught it for a long, long time. And then we got the internet, and we're like, oh wow, you can look up anything on the internet. So it's just a couple years ago, to tell you the truth, and I've been teaching 24 years now. All right, so I just looked up on the internet, and doesn't take you but 5 minutes, and you can find it. All right, so let's do the slope. Let's find this.
Really debate over what M means.
That, well, yeah, they do, or where it comes from. Absolutely. Let me show you another thing. Okay, what a lot of times we'll say this. We'll call it the change. I'm going to show you a lot of different ways. It's not in this room, is it? Change in y over the change in x. You'll hear people say this all the time. You'll hear the change in y over the change in x. So if I go from one y value to another y value, that's the change in the y values, isn't it? You're going down the highway. You're at the 5 mile marker, and you're going to go to the 7 mile marker. What is the change in your distance from 5 to 7? It's what? It's 2. Agreed? So that's why you subtract. Does that make sense? And that's, I want to throw these words out here because a lot of teachers will just throw this out here. They'll say, what's the slope? Oh, it's the change in y over the change in x. And you're like, what? What does that mean? Well, the change is to go from one to the other. And how do you do that? You subtract. Make sense? Now I'll show you another crazy thing. All right? I don't know if you've seen this, but they actually have a Greek letter. So now we went from Latin to Greek, okay? There's a Greek letter of the alphabet that represents this little phrase, the change in something. Tell me if you've ever seen this. It's called a delta. Very good, okay? And you have seen that. It kind of looks like a triangle. And I think they kind of, they darken one end, but I don't usually darken one little side in. But it's a triangle. It's a delta. You ever see people walk around with these you know, sweatshirts and t-shirts and stuff like they're in a fraternity or sorority? They got all these Greek letters on their shirts. Yeah, you've seen that all the time. Delta is a popular letter, the Greek alphabet that they use for these things. All right.
Sammy's dorm used to be like right behind several frat houses.
And one of them probably has a delta on it, would be my guess, because it's a very popular letter. I was never in a fraternity. We didn't have fraternities at Liberty, so I don't know all about which ones are which and that kind of stuff. But I know we got a couple minutes. I always tell the story.
I just know I saw a bunch of buildings with Greek letters.
Right, exactly. So it just kind of reminds me. I don't know if you this goes way before your time, but you could probably even look it up on YouTube. But there, Saturday Night Live used to have a sketch where this girl, she was like this sorority girl, and she was like all valley girl, you know, talking to stuff, and she would answer the phone, and her sorority was Delta Delta Delta, right? And she would answer the phone. Do you know the skit? Yeah, it was hilarious, wasn't it? And she would say, Delta Delta Delta, may I help you, help you, help you? And that was her catchphrase. And then in school, people would actually say that all the time, you know, because you hear stuff on TV and everybody repeats it, and so that was actually a catchphrase for quite a while. So look it up on YouTube. It's actually kind of funny. Morgan was laughing. You remember? Yeah, it was a pretty funny sketch. So anyway, they use this. It's the change in y over the change in x, and we use that delta to represent the change in something. So there's all kinds of ways you could look at it. You could look at it as rise over run. I didn't even write that in here, did I? Rise over run. I could throw that in here. All these different things mean the same thing, but I want to throw that out to you because if you go to college and your professor says, okay, slope, delta y over delta x, at least you know what they're talking about, okay? And I think that's important. So let's actually, you don't have to write all this stuff out when you're doing this problem. I just thought I'd throw that in there for you. So how do we do this, the change in y or the change in x? Well, we take the y's, and what do we do with them? We subtract them. That's right. We subtract them. And it doesn't matter what order you subtract them in as long as you subtract the x's in the same order. You follow me? I usually just do the first one minus the second one, no matter if they're positive or negative or if your answer comes out positive or negative. I just like to stay consistent. I just go the first one minus the second one. So it's going to be 1 minus 7. Now notice what I subtracted. I subtracted the y's, right? Because it's rise over run. So many people mix this up. They always do x first because, x comes first in your x and y, your ordered pair, and people subtract the x's and put it on the top. But it's not. It's not run over rise, is it? It's rise over run. The rise is the y, the run is the x. So let's subtract the x's in the same exact order, and it has to be subtracted in the same order. Okay, so if I went the first one minus the second one, I have to do the same thing with the x's. So what's the first x? -3 minus 5, and let's see what that is. That's -6 over -8. We don't leave it like that, though. We always simplify our fractions. Reduce it. If it's negative over negative, don't leave it negative over negative. I've seen so many people leave answers like that, and I wouldn't mark it wrong, but it just bugs me, all right? Negative over negative is what? Positive, right. So you know it's going to go to positive. What happens here? 2 goes into this, 3 times into this, 4 times. So what's the slope of that line? It's 3/4. And you leave it like that. Don't put it into a calculator and get 0.75. Leave it 3 over 4 because you see the rise and you see the run. That's how I want you to see it. All right? We good with that? Look, I started this from scratch, okay? I didn't make any assumptions that you already knew this stuff, even though you have been taught it many, many times, okay? So some of it, is, you probably heard many, many of these things that I taught you already, but I wanted to start from scratch because I didn't want to assume that you knew how to do this stuff. They're going to give you another problem like this. They're going to actually ask you to graph it. They're going to say, graph a line that goes through... I'll just write that down. Let's just make up a point, -1, 2. All right? We're going to graph a line that goes through the point, -1, 2, and has a slope of, I don't know, 3/5. Just made that up off the top of my head, okay? So how do we do this? Well, we got a graph. So the first thing that we want to do, let's do this in another color. Let's go red. First thing we want to do is plot this point, -1, 2. So let's plot it. -1, 2. Let's put a few in here. We'll go 4. And we may need some more, but we'll... Alright, so there's a nice little graph right there. We plot -1, 2. -1, +2, that would go right there. That's my point. And then it says it's got a slope of 3/5. Well, what does that mean? It means we're going to start from this point. We're going to rise how much? 3, and we're going to run how much? 5. Okay, so that means, what do we do? Let's put another thing on here. We rise 3. That means we go up 3 places. 1, 2, 3. Don't put a dot here because we still have to do what? We got to run how many places? 5. That means we go to the right. It's positive. We go to the right. So watch. 1, 2, 3, 4, 5. That would put you right there. You got 2 points, so what do you do with those 2 points when it says to graph it? You just put the 2 points and nothing else? No.
Sure, why not?
No, not why not. We extend the line. Right? Extend it like that. Don't just put it between the 2 points. I mean, that wouldn't be wrong. It just doesn't look that great. We want to extend it so it looks like it keeps on going forever. You don't absolutely have to put arrows on there, but technically arrows would keep on going. It keeps going in both directions here. And that would be it. It's as simple as that. Okay, so that's all you're doing on the worksheet. You're doing these 2 problems basically. They give you 2 points. They give you 2 points, and you have to find the slope. All right. Now you don't have to write all that junk in. All you got to do is this right there. Okay, that's all the work involved. Very, very easy. I mean, this homework literally would take you maybe 5 minutes to do. Okay, and then you do this. It says to graph the line that goes through this point, has this slope, and that's what you do. So that is your answer right there, that whole entire graph. And they even give you a little graph on the worksheet, which is nice of them. All right, we good with that? Pretty simple stuff. Real basic. Tomorrow we'll get into a little bit more of solving for x, and then eventually y equals mx plus b. Remember that, don't you? Slope-intercept form and all that good stuff. Yeah, so that's where we're heading with this stuff. All right, so now you know. All right, so the worksheet is 3.3a. That's what we called it.